In this lesson, we're going to take a high-level overview of queues in general. Think of queues a lot like a secretary. The secretary can take calls and post messages to your desk. If you're at lunch and you come back, you can check the messages and choose to act upon them. You can basically batch process the work. Think of queues like a secretary either for the whole office, where maybe multiple workers can check the messages on your desk, or per workload, where maybe one secretary takes marketing messages and another secretary takes engineering messages. Post-it notes, or queues, allow for efficient, scalable systems. Multiple outside callers can call up and leave a message, and multiple workers can process through the message list. You can add more workers if the message list gets too deep, and if a worker gets sick, the message is still there on the desk when they come back. This is what's known as a loosely coupled system. Tight coupling is not a good thing. Think of the instance of a client calling up. If the salesperson's there, they can talk to them, and that's great. But in this scenario, we don't have a secretary, so the salesperson has to be there. The salesperson can then call the product team, who can then maybe call the engineering team, and actually get some work done. If, however, we have a tightly coupled system, and the salesperson's out at lunch, the whole thing dies. We have tight coupling and everything is broken now just because one of the components failed. Queues enable loose coupling. So if we have the same client, sales, product, and engineering groups, and we're instead using queues, the client can call and leave a message on that queue. The salesperson can pull it. The salesperson can leave a message on the product team's queue. The product team can pull it. And the same for engineering. Now if that salesperson gets sick, the message is still in their queue. So when they come back, they can pull it. But now maybe there's a whole bunch of messages waiting there. So when the salesperson dumps on the product team needs to bring in additional consultants to get through the workload. This allows for scaling by tier. We just scaled up the product team, and no other scaling needs to happen in any other tier. Software often uses what's known as a service-oriented architecture, or SOA, where we have a service bus. And along this service bus, we have many individual components, each of which is a specific workload. For example, a customer places an order. We first validate their credit card, then we verify we have inventory, then we ship the product, send the customer a thank you email, and perhaps update the customer record so we can make recommendations to them later. Although queues look to be very simple, they're actually pretty involved, both from a mathematical perspective and in the number of types and functions available to each. In the broader perspective, there are many types of queues. There are FIFO, or first in, first out buffers, LIFO, or last in, first out buffers, and priority queues, which rank certain messages as higher priority than others. SQS is close to, but not exactly the same, as a FIFO buffer. Software queues also typically include a lot of functionality that's just not available in SQS as of yet. These include dead letter queues, in which a message that wasn't deliverable at least is logged so we can review it later, transactions, in which we may have an atomic operation that needs to happen, and rollbacks, where if any part of a transaction broke, we can roll back the entire transaction. SQS doesn't include any of these features. Building queues is a tough problem. You have to think about redundancy and high availability. You have to think about the latency, the durability, and the feature set. There are many options for building queues. Some of the more popular ones are RabbitMQ, Apache ActiveMQ, JBoss Messaging, Oracle Message Broker, and SQS. In summation, queues enable loose coupling. They also enable scaling by tier. Software will often use a service-oriented architecture, which works very well with queues. Queuing is a tough task with a lot of moving pieces, and there are a lot of options to choose from, one of which is SQS from Amazon.